This is a quick explanation of the lifting barrier project. The model's quite easy to make. We've got a servo over here glued to a little wooden block to get it the right height, and the servo arm is connected to this string here, this straw here, to act as the barrier. The sensing side of the project here, we've got a light-dependent resistor, and above that we've got a LED shining onto it. So that ensures consistent light to the light-dependent resistor. And the way the barrier works is when the car drives up to the car park barrier, they put their card over the card reader, and in this case it's just the LDR light level is reduced, which gives a higher input value to the microbit. And we just by experimentation discovered that if the input goes above 100, that's a good value to lift the barrier. But that's found by experimentation. So the circuit looks quite complicated here. So just to break it down, obviously this is the power supply to the microbit. The power supply over here is just to the servo. So if you follow these wires here, this positive wire is the servo's positive, in this case 6 volt. The negative is the servo's negative wire. This also has to be connected to the ground on the microbit, because the microbit is controlling the servo, so it has to have a link, a negative link to the servo to complete the servo circuit. Because the third wire from the servo, the input, the control wire, is connected in this case to pin 0 of the microbit. And so if we just connected the servo to pin 0 without having ground, then our servo circuit isn't complete. But the power, the 6 volt power, is coming from here. The two components over here, the LED is simply connected using the red and black lead. Remember, it's got polarity. It's connected between the 3 volt output on the microbit and ground. The LDR is a sensor, it's a resistance sensor, so we've connected it in a voltage divider circuit. So instead of simply connecting the 2 legs from the LDR via wires to ground and to the input pin, in this case pin 2, what we've got here is a voltage divider. So from the pin we divide the circuit via this resistor here, and so from one leg of the LDR it's a direct connection to ground over here, but from the other leg we come along this wire, then we divide. One side goes to the input pin, in this case pin 2, the other side goes to a resistor and then to the 3 volt pin. And that resistor needs to be similar to the resistance of the LDR under normal operating conditions. So with a multimeter, you need to find out what the resistance of that LDR is when the light's shining on it, and if that's, say, 330 ohms, then, or close to that, you need to get a resistor to match 330 ohms. But the wiring is explained in the LMS. This is just to show you what it looks like and how the system operates by cutting out the light level. And the code is on the LMS.